So this is the second video going over this reference page, parent function reference page. Oh, well, if I can get this PowerPoint to pull back up. There we go. All right, so we're flipping over to the back of that reference sheet. Okay, we're going to look at exponential. Okay, so some things that you want to add in, things to remember on that worksheet, that paper. Why is it not? There it goes. All right, so general form, exponential function, remember, had x in the exponent. Okay, so in the general form of the equation, we have that base b. So the minus h is always subtracted inside the function. So for an exponential, inside the function is in the exponent, because that's where x is. Okay, and then k is added on the outside, so it's plus k here. This is not in the exponent. And then, of course, if there is an a value, that's the coefficient in front here. Okay, now that a value, if it is less than 0, if it's negative, that's going to cause this graph to reflect across the x-axis. So instead of increasing rapidly, it would be decreasing rapidly. Okay, so if that a is negative, that's going to do a reflection across the x-axis. Now, b is greater than 1. If this is a positive number, this base, that is exponential growth. Okay, the function is increasing. Pretty good with that? If that b is between 0 and 1, so it's like a half, a third, 5/8, some fractional decimal value between 0 and 1, that is exponential decay. Okay, your function will be decreasing. And that graph is going to look a little bit different. It's going to be a reflection over the y-axis. Okay, so instead of increasing rapidly like that, it's going to be here. It's going to be coming down. It's still going to have the asymptote along the x-axis. It'll be up here, reflection across the y. So this is exponential growth. If that value for b, your base value, was fractional, it would be exponential decay. Okay, and again, that horizontal asymptote is always there in exponential functions. It's at y equals k. Okay, whatever this number is that's being added out here, that tells you where your horizontal asymptote is. And the parent function, there's nothing being added at 0, so that's why it's y equals 0. But if there is a number here, that means your asymptote has been shifted. Everybody okay with that? Things to remember, things to know. All right, now let's talk about logs. We said yesterday that the log function is the inverse of the exponential. Okay, so the general form here, similarly, we're going to have a base b on our log. Okay, the h, the minus h, is going to be inside the function with the x. In this case, it's inside the log, what you're taking the log of. Okay, plus k is on the outside of the log, outside of the function, and a is the coefficient in front being multiplied by the function. Okay, what you need to know is that log functions have a vertical asymptote, and that is set to the expression inside the parentheses. So here, the x minus whatever is here inside the parentheses, we set that equal to 0 and solve for x. And when we do that, we'll get our vertical asymptote. Now the a value, When it is positive, when it's greater than 0, this is logarithmic growth. Okay, our function is increasing left to right. But when that a value is negative, we have logarithmic decay. The function will be decreasing. It'll be a reflection across the x-axis. So it would be coming down, it would still cross here and then leveling out there. Not leveling out, but decreasing at a slower rate. Okay. Now, if your b value, the base of the log, if it is a fractional or decimal value between 0 and 1, kind of like we talked about for the exponential, okay, that will also make it a decreasing logarithmic decay. Everybody good? Some people still writing. Give you a few more seconds. All right. Next one we're going to look at is the rational function. So the rational function, this is the one that had both a vertical and a horizontal asymptote. Okay, so here's the general form. Okay, remember x is in the denominator. So the minus h to be inside the function is going to be in the denominator with it. Same with b. And then a is in the numerator. K is added on the outside. Okay, we talked about how those have both vertical and horizontal asymptotes. Okay, your vertical asymptote, to find any vertical asymptotes, you set the denominator equal to 0 and solve for x. Set the denominator equal to 0 and solve for x. That's going to give you your vertical asymptote. Okay, now your horizontal asymptote is going to be the line y equals k. So whatever this k value being added on the outside is, y equals that is your horizontal asymptote. Okay. Now, the domain and range are affected by the vertical and horizontal asymptotes. So the vertical asymptote, the one going up and down, is affecting the domain, and the horizontal asymptote is affecting the range. Okay, so keep that in mind. Once you know where your asymptote is, that's the restriction to your domain. Or if it's the horizontal asymptote, that is the restriction to the range. That's where that union would happen. Everybody good with that? Okay. All right, the next 3 functions on that worksheet, that's the end of this slideshow. It doesn't have the trig functions on there, but we'll look at them. Let me pull it back up. Okay, are the trig functions And I don't know that we need to go over these as in much detail because we've talked about them most recently. I guess let me get it copied over here to a new page. We can jot a few things down about them to make sure you remember. So when we were first graphing these trig functions, these sine and cosine waves, those sinusoidal waves, we talked about the equation was in this format. We used A, B, C, and D when we did this. So I'm just going to keep it how we talked about it originally with A, B, C, and D instead of trying to switch it over to H and Ks. But we talked about how the A value is what's multiplied in front of the trig function, the coefficient there. And then you could have inside the trig function, you could have B, and then, well, it was bx plus c if there was no parentheses. We actually talked about it in two formats. And then you had plus d on the outside. And then we talked about how A is the amplitude, right? Just taking it back a little. The absolute value of A, I should say, was the amplitude, and how B helps us determine the period of the function, the period of the wave was 2 pi divided by B. Or vice versa, if you knew the period and you wanted to know B, B is 2 pi divided by the period. Or 360 if you were in degrees, right? And then we talked about how C, when it's in this format, C is not the horizontal asymptote, or excuse me, the horizontal shift. The horizontal shift was the opposite sign, and it was after you divided the B out. So it was C divided by B. And that the vertical shift was D. Okay, and that there was the midline of the graph. And the parent function is here. Remember, we draw the midline, the center, the like equilibrium line of it was just y equals d. Okay, and that tells you your vertical shift. Now, I'm not going to write all of that down again for cosine because it's the exact same information. You literally just change the sign to a cosine. But I am going to write, we talked about writing it in the format where the b was already divided out. And when you did that, when you divided out, if it was in this format where the number was already factored out and you just had x minus some number in here, that number is your horizontal shift. And that the number added on the outside is your vertical shift. Okay, so you may recall us having it in this format. Okay, but the A is still the amplitude, the absolute value of A is still the amplitude. And B is still used to determine the period. Y'all remember all this? Somewhat recently, we did that just a couple months ago. Really? No, we did not do much with tangent. The one thing that we did talk about because we didn't do practice with graphing tangent or anything like that. We just talked about the parent function. There's not a ton you need to know about it. That's not what I meant to read. Okay, so what I would put there just as a reminder is that the period of the tangent graph up here, when we did the period for sine and cosine, we did 2 pi divided by b because the parent function period is 2 pi. But in the tangent function, the period, okay, the number of radians or degrees before the graph starts repeating itself is only 1 pi. So that is one thing I would put on here because it's different for tangent, is that your period is pi divided by b instead of 2 pi divided by b. Okay, it had a shorter period for the tangent graph. Okay, that's all I would jot down there as a, because that's the one thing that's different. Y'all feel okay about those? Now keep this reference sheet handy. Like as we go through this unit, if we come across something or talk about something and you're like, wait, I don't know if I'm going to remember that. You can always go add it to this reference sheet for things, because you want to have this to be able to look back on to help you through the whole unit. Okay, so feel free to add things to it as we go if you need to. I think we hit most of the main points, but just in case, just know you can always add things to it. All right. All right, we're going to do some practice over all of this tomorrow.